Hello friends, welcome to this online course where I am going to share my knowledge of operating system subject. My name is Ketan Pachpande. I completed my BTech from VJTI Mumbai and MTech from IIT Kharagpur. And since last 9 years, I have been working with the product-based company where my area of expertise is storage. I have been also sharing my knowledge to the GATE aspirants and helping them enter into IITs. So let's get started with our course. This course is for anyone who is willing to learn the concepts of operating system. I have designed this course specially for the GATE aspirants. The students appearing for their semester examinations can also go through my course. And those students appearing for product-based companies interviews such as Microsoft, Google, Cisco, Adobe, etc. For those interviews, operating system concepts definitely going to help you. Prerequisites to learn this course is you need a passion to learn all the concepts of OS, and since there are a lot of videos I am going to create for you, you need to have patience to go through all my videos. From the technical aspects, you need the basics of C programming or C++ programming, where you should know how to declare the variables, how to define the functions, how to pass the parameters to the functions, what are the different control statements such as if statement, if else control, while loop, for loop, etc. Few tips before we jump into the syllabus. Since this is an online course, my strong recommendation is take a pen and paper and start noting down the notes in your own with your own understanding. Whenever I am going to draw any diagrams, redraw them on your notebook. We forget the things easily what we see or what we listen, but if you keep on writing the notes, you will barely forget them in the future. Let me brief the syllabus here that I am going to cover in this course. First, I will discuss the introduction to the operating system, followed by the chapter process management, in which I will be teaching you how the process is created in the operating system, what is the process structure, what things operating system stores inside the process structure, etc. The second topic I would be discussing is CPU scheduling. This topic is required because in operating system you must have seen there are several processes which are running concurrently, but there is only one hardware you have, that is CPU. That's why to make the decision which among these processes will run in the CPU, we require the CPU scheduling algorithms. Next, I will go through the inter-process communication, synchronization and concurrency. This chapter is required when two or more processes needs to communicate with each other, and while communicating with each other, what problems they face. For example, race condition. So how to solve this race condition also? What are the different synchronization techniques? So that all we are going to learn here. The next topic under process management would be deadlock. To give the simple analogy, you must have stuck in a traffic jam sometime, and after some time traffic police comes there and overcomes that deadlock. So here also we will learn how the process can enter into deadlock scenario and what are the different strategies operating system implements to get those process out of deadlock or to design the algorithms in such a way that deadlock will never occur in the operating system also. I'll talk about the threads also. Thread is a part of process only. I would say thread is a small process only, but it is inside the process. In one sentence I can say it is process within a process, and you can create multiple threads in a process. Why threads are required? To execute different pieces of code concurrently in the same process. To give the example, when you type something on any text editor or let's say Microsoft Word, as you keep on typing, Microsoft Word checks the spelling and the grammatical mistakes in the background also, and it highlights it. So The software is nothing but running a thread in the background which is continuously monitoring your text and produces some output for you. The third chapter I will be discussing is the process management, under which first I will cover what are the properties of the memory, for example size of memory, addresses of memory, etc. How the memory is allocated to the processes. So here we are going to discuss about the RAM, random access memory, which is a volatile memory. So when a process is created, how the operating system allocates the memory to different processes. So we have two techniques here, contiguous memory allocation and non-contiguous memory allocation. And one of the very important topic under memory management is virtual memory. Why we require this concept is, if we want to execute a larger or bigger process than memory size, then virtual memory concept is useful. Let's say your memory size is 1 GB and your process size, let's say you are playing a big game or you are loading a big software like Photoshop. It requires more memory. So that's how we will learn how OS manages the execution of bigger processes in smaller memory. The last chapter I will be discussing is the file system and device management. This chapter is all about how to store the data on secondary disk. So first I will go through the characteristics of secondary disk. I am going to cover the electromechanical type of disk and not the flash disks. I am not going to cover the pen drive or let's say SD card, etc. I am going to cover the properties of the physical properties of the electromechanical device. Next, I would be covering the file allocation table, means how the operating system allocates the space on secondary disk for a file which you are going to copy or create on it. For example, let's say you have 16 GB of pen drive or let's say secondary disk, and on which you are going to copy or create 2 GB of file, let's say a movie. Then we will learn here how out of 16 GB, 2 GB is allocated to the file you are going to create. Next topic is quite important, which is disk free space management, which talks about how the OS keeps track out of this total disk space. Let's assume 16 GB, how much is the used space and how much is the unused, means free space. You know that the secondary disks are non-volatile, meaning is that when you detach the secondary disk from any machine and attach it to another machine, we are able to read or retrieve the data from that disk in that other machine also. And why it is possible? Because of the standard algorithms we have, the OS implements. And that other machine needs to know out of the total size of this disk, how much is the used space and how much is the free space, so that user on that other machine can take the actions on that disk. We are going to discuss the two case studies, how the Linux stores the files on secondary disk. It uses the concept of inode. I stands for indexed. And we will learn how Windows operating system stores the file on secondary disk. It uses the concept of file allocation table. So let's start with our first chapter, that is introduction. So what is an operating system? Operating system is an interface between user and hardware. Many articles, many books have stated this definition. Let me demonstrate with the help of this block diagram. Let me take, this is your hardware and this is the user. Let's assume that when you buy a laptop from the market, or let's say mobile from the market, and you as a user want to use the hardware, it is nothing but the hardware. So with that laptop or mobile, there is an inbuilt operating system installed there, with the help of which you use the hardware such as speaker, mouse, keyboard, etc., monitor. The hardware consists of mainly two parts. First is the central processing unit and other is the memory attached with the central processing unit. If you know, these all hardwares are attached, what we call that circuit as motherboard. The memory are of two types, primary memory and secondary memory. The types of primary memory are RAM, ROM, cache and registers. Out of these four memories, cache and registers are internal part of CPU hardware only. And RAM and ROM are out of CPU hardware. The second type of memory is secondary disk. Secondary type of memory means they are non-volatile memory. Means even if power goes off, the data remains on those secondary disks. For example, hard disk, DVD, pen drive, SD card, etc. These secondary disks are assumed as I/O devices which is attached to the machine but not directly attached to the CPU. So CPU can't understand these secondary disks directly. CPU only understands the primary memory only. So the job of CPU is to get the input from user, that is nothing but the instruction and data from the user. CPU executes it and produces the output. CPU internally has two parts, two modules or two units I can say. One is the control unit and other is the arithmetic and logical unit. What is the difference between these two units within the CPU hardware? Control units acts as a bridge between CPU and other devices such as memories. And control unit tells the ALU that here is the instruction I have brought from the memory and now you execute it. And ALU is able to execute the instruction or it is able to access any data only when it is brought in the CPU, in the local memory of CPU, that is cache and registers. Alright. So ALU cannot talk outside the CPU, only CU can talk outside the CPU. And ALU is the heart of the CPU which executes your arithmetic and logical instructions such as add instruction, subtract instruction, multiplication, logical instructions such as OR, AND, etc. So in short, CU controls the data flow in and out of CPU. ALU cannot do that. Alright. The other definitions of the operating systems are, it is purely a software which understands the language of hardwares such as CPU, memory, disks, keyboard, mouse, etc. It is also known as resource manager. Resources are of two types, software resources and hardware resources. Software resources are some files of the operating system. Semaphore, we are going to learn one of the very important topic in OS, that is semaphore, in the synchronization chapter, and the device drivers, etc. The hardware resources are nothing but your monitor, mouse, keyboard, RAM, CPU, etc. Operating system provides a set of utilities to simplify the application development. Remember that the end user is not the only user of the operating system. The developers like you and me, which belong to the computer science and IT background, which creates a software on a particular operating system, to run on a particular operating system. In order to run those applications on a particular operating system, the OS needs to provide some functionality to the developers also. OS is also a set of processes. Those processes we call at host processes or kernel level processes. And whatever programs or whatever processes we create, let's say I play a game on operating system, that process is the guest for the operating system. Examples of the operating systems are Windows operating system, quite famous and widely used. Linux operating system, Android used in the mobile is in the mobile hardware, iOS and Mac OS in Apple devices. So how the user interacts with the operating system. OS internally has two levels, I would say. When the OS wants to give some commands to the operating system, it gives the command via some tools. For example, shell is a command prompt tool given by the operating system both in Windows and Linux also, with the help of which you can give the command, and with the help of that command, operating system takes the input, it runs some kernel level programs and produces the output for the user. Kernel level programs are the one which can understand and or talk to the hardware and produces the output. Another tool which is widely used is the GUI, graphical user interface. In the we call that tool as desktop also. When you boot the Windows operating system, a desktop tool is created where you can see the start button, where you can see the list of applications also. So it's the tool provided by the operating system to ease the users' activities. Other type of users are developers, I would say, which require to call some functions of the operating systems programmatically. So OS needs to provide some application programmer interface or some system calls which programmer can call from the programs like C, C++, Java, etc. and develop an application for the end user. So I would say these are the user interface tools which ultimately talks to the hardware interface, that are the kernel level programs, and produces the output for user. Let me explain how the operating system executes the program right from user writes any program in C or C++ or any other higher level language till the operating system executes the instructions of this program. So let me assume that I write a C program here, A is equal to B plus C. I have declared them above. Let's consider these are the integer variables. When you compile this program, what is generated is the set of assembly instructions. You must have learned in the compiler subject how the assembly instructions are generated by the compiler. And I will explain you whenever they are required. As of now, let me explain these 4 instructions here. So, corresponding to this one statement, we have 4 assembly instructions here. The first instruction says that bring the value of B from memory into the local register of CPU, which is R1. Similarly, bring the value of C, and then the statement is add, which will be executed by ALU, because add is an arithmetic operation here. So ALU will add 2 variables here, R1 and R2, and store the result in R1. And the last instruction is here, store the result, that is from R1, at the address of A, in which I want to store the addition of 2 variables. The next tool is your assembler, which converts the assembly instructions into the binary instructions. So this is how the binary instructions look like. Everything is in the 0 and 1 format here. So binary instruction contains 2 things. First is the operation code and other is the set of operands. These binary instructions along with the data are stored onto the secondary disk. In some file, what we call that file as executable file or program. When user says that I want to run this program is first loaded in memory, that is your RAM, by the operating system. These instructions stored in the program are loaded in memory instruction wise, one by one. So here instruction 1, 2, 3, 4, etc. are loaded in a sequential manner in the memory. And once it is loaded in the memory, the CPU can now start the execution of these instructions. Remember that OS first needs to bring this program in memory. Then only CPU can start the execution of these instructions. So let me take this set of instructions. Whenever OS loads these instructions, every instruction is given an address. Here, let's assume that I have shown it in decimal here, but certainly the address is in binary. You learn in memory management how these addresses looks like in binary. As of now, let me take the addresses in decimal only. So 34 is the address of instruction 1, 35 is the address of instruction 2, and so on. So this is my CPU, which has internally two units, CU and ALU. Let me tell you what are the things inside the CPU which are needed for execution of program. So these are the internal memory locations within the CPU. What we call them as registers. So here is the first register, which is called as instruction register, IR. Second register is called as program counter, stands for PC. And there are some general purpose register, R1, R2, etc. There are some standard names, but here I have just named them as R1, R2, R3, etc. Instruction register's job is to hold this instruction from memory. Okay. So I am going to just copy this instruction from primary memory, that is I1, here into the local memory of CPU. Now how the CPU will know which instruction I want to fetch, that is which instruction I want to copy from the memory and execute it. And that's how the program counter is useful. So when the program is loaded in memory, we have to OS initializes the value of program counter of CPU to certain address. What should be this address? You know that in C++, the execution of program starts from main function. Let's assume that this is my main function's instructions. Alright. And I want to start the execution of instruction stored at address 34. So what OS will do? OS will initialize the value of program counter and tell the CPU that I have initialized your program counter. Now you start the execution of instructions. Now what CPU does is, it looks at this program counter value, it goes to memory and it fetches this instruction from memory and copies it to local memory, that is your instruction register. So just I have the second copy of this register, which the operation is called as fetching, and CPU has brought the instruction 1 into the local memory. And now it is good to execute that instruction. CPU executes any instruction in 4 stages. So let me explain the 4 stages. You will learn this all 4 stages in details in the subject Computer Organization and Architecture. I am just giving you the overview here. So first the CPU fetches the instruction from memory into the instruction register. The next thing it does is it increments the program counter to the next instruction. That is, in our case, the initial value was 34, and now once it has copied the instruction for 34, it will simply increment the value of 34 to 35. And CPU always increments the value of program counter by one instruction only. The next stage is decode the instruction, means CPU reads the operation code of the instruction and then it executes the instruction. It tells the ALU to execute the instruction. And then the cycle repeats, and that's how all the instructions are executed in a sequential manner, one by one, by the CPU. Whatever I have explained is called as von Neumann architecture. So according to von Neumann architecture, first the program needs to be stored or brought in main memory. So program instructions and data first must be loaded in memory and then only CPU can start the execution cycle, the stages I have just explained. The instructions will be fetched in a sequential manner only, because program counter is always going to be incremented by 1 by the CPU. It always assumes that the next instruction is stored at the next address only. Okay, and that's how the CPU has already made that assumption. So before CPU starts the execution, the OS needs to load all the instructions in a sequential manner in memory. So in other words, CPU cannot fetch the instruction directly from the secondary disk. Even if the same instruction is stored in secondary disk, CPU cannot understand the addresses of the secondary disk. So the sequence of execution is, first OS brings the program in memory, and one by one CPU brings the instruction in instruction register and executes them. Let me discuss the functions of operating system, starting with the CPU scheduling algorithm. So this is one of the main function of the operating system, main job of the operating system. Why? See, there are several processes OS can run concurrently. You see, you can learn some song in the background while you are doing some work in some notepad or text editor. You can open multiple applications also. But you have only one hardware, that is CPU. And assumption is that CPU can only execute one instruction of one program or one process at a time. That's why OS needs to implement some CPU scheduling algorithm which decides out of n processes which are loaded in memory, which one to schedule next to the CPU. The next function of the operating system is security. See, there is only one memory and one CPU. So it should not happen that a process is disturbing or a process is modifying the data of other process or accessing the data of other process. You can call those processes as virus also. So OS needs to make sure that one process should not access or modify the data of other process. So the security is one of the very important aspect of any operating system. There are several security aspects operating system needs to implement, such as firewall also, which mainly deals with the networking security. The next function of the OS is memory management. We have only one memory, that is RAM, and multiple processes which are going to use the same memory. So that's why OS needs to manage this memory also. OS also needs to manage the files on secondary disk, that is nothing but the file management. The goals of the operating system, first is the convenience, where whenever any company designs any operating system such as Android, such as iOS, Windows operating system, Linux operating system, the first goal they want to keep in mind is operating system should be easy to use for the end user, right? If it is very complex, end user won't be able to use it in its daily routine. The second goal is efficiency, which makes sure that the OS uses the resources efficiently. The third goal is the portability, meaning is that the operating system should be able to install in many hardwares. For example, Android operating system can be installed in Samsung mobile also, and can also be installed in some MI mobile also, right? Different companies can use the same operating system. That's because that operating system has provided the support for those hardware. Scalability, you should be able to run many applications in the operating system. Reliability, which deals with the no failures in the operating system or no damage to the user's data. One of the very important aspect is robustness, which also deals with the errors. But difference between reliability and robustness is, when we say that the operating system is robust, means if a small error occurs in the operating system, OS should not damage all the processes. Okay, it just should say one process is giving some error and because of that I am terminating this one process. Sometimes you may observe that entire operating system hangs and the only choice you have is to restart the operating system. In that case, I can say the operating system is not robust. Out of these goals, according to the type of user, the goal become primary. For example, for the kids or parents, we say that the convenience is the primary goal. Let me discuss what is the real-time operating system, which is also called as RTOS. The operating system which generates the response in restricted time only is called as real-time operating system. Real-time operating systems are of two types: hard real-time operating system and soft real-time operating system. In hard real-time operating system, there is a strict deadline for each and every task the OS is going to execute. If the task runs beyond the expected time, then there is a chance of much damage to the data or process. For example, in aeroplanes, rockets, metro trains, even if a small error or the delay in response of some execution can cause the huge damage. So that's why those are called as hard real-time operating systems. Whereas in the soft real-time operating systems, the deadline is flexible. Means even if the tasks execute beyond the deadline, the damage is less. For example, in ATM machine, in the fridge, TV, these have the soft real-time operating system. Even if there is some delay in response in ATM machine where you are withdrawing some money, then the ATM machine says that timeout occurs and you just retry. There is no as such harm to the user as compared to the aeroplanes and rockets. The primary goal of this real-time operating system is reliable and robustness. This is the end of our topic. In the next session, I am going to talk about multi-programming versus uniprogramming. Thank you for attending this session. See you in the next video.